The next common skill you need, go back to page 1, okay, is when you see something like f prime x over fx. Okay, why? Let's differentiate ln fx. Previously in your differentiation chapter, what are you going to get? F prime x over fx, the differentiated of the original. So again, I ask you, is your differentiation good enough to come to this chapter? Okay, if it's not good enough, practice on differentiation first. Which means that if I can identify a quotient where the numerator is a differentiated of the denominator, what am I going to get? It will be ln of fx because of Mr. A, this is Mr. A, this is Mr. B. Integrate Mr. B, I'm going to get Mr. A. So when you see a quotient like this, what is going to happen here? My fx is the denominator, which is 1 plus sine x. Differentiate the denominator. Differentiate sine is cosine x. So I'm going to, is this my f prime x? Yes, it just satisfies that f prime x over fx, the integral of that is going to be equals to ln modulus of 1 plus sine x, okay, plus c. Also, this technique here is also the next most common technique that you are supposed to know in H2 math integration. The first one being f prime x fx to the power of n. The second one being f prime x over fx is equals to ln fx. One more. If I differentiate e to the power of fx, I'm going to get f prime x, differentiate the power, put in front, e to the power of fx. Again, Mr. A, Mr. B method. So the integral of f prime x, e to the power of fx. What am I going to get for this? Is equals to just e to the power of fx. Why is the f prime x missing? Just like your chain rule, the f prime x is a result of the differentiation. So when I integrate an f prime x together with e to the power of fx, it will be gone because integration is a reverse of differentiation. Okay, and that is the thing that must be in your mind when you do integration question. Okay, so I'm going to dive in to this. If you look at if you look at C, the integral of 7x e to the power of 5x squared plus 3. There's no way you can immediately write down the answer for this. I'm going to tell you that there's no way. So in order not to screw up, let's just think. Now this is a Mr. B. What do I differentiate to get this guy as a result? I'm thinking of Mr. A, which is, if I differentiate e to the power of 5x squared plus 3, what am I going to get? Differentiate the power, 10x. Put in front, e to the power of 5x squared plus 3 remain. Yeah, so if you can see this, you don't even need to memorize f prime x e to the power of fx, okay, as a formula. Now I know I need the 10x to accompany. I take out the 7, I integrate, I need a 10 over here, so I need to divide by 7 over here. Okay, so what is the integral of this? Differentiate Mr. A, I get Mr. B. Integrate Mr. B, I'm just going to get Mr. A, e to the power of 5x squared plus 3 plus c. Okay, so you don't have to really kind of memorize. Yeah, next one, the integral of x squared over x cubed plus 1. Check if the numerator, if the power of the numerator is greater than the power of the denominator. If ever it is greater or equal, first you have to do long division, but in this case it is not. Okay, so if it is not, then let's look at this. My fx is equals to x cubed plus 1. Okay, so what is my f prime x equals to? 3x squared. So I know I need to have a 3 as the numerator, so this will be 3x squared over x cubed plus 1 dx, and that is how, okay, I'm going to apply the integral of f prime x over fx is equals to ln modulus fx plus c. I'm just going to write down the result, ln modulus x cubed plus 1 plus c. Okay, and this is the second technique that you have to know, which is very common. The first one being the integral of any f prime x e to the power of fx is equals to just e to the power of fx plus c. Next is the integral of f prime x over fx is equals to ln modulus fx plus c. So these are the next two techniques that you are supposed to know very well before we can move on.